In simple terms, blockchain is like a digital ledger or record-keeping system that securely stores information across a network of computers. Imagine a chain of blocks where each block contains a list of transactions or records. Once a block is filled with transactions, it's added to the chain in a way that makes it almost impossible to alter or delete any of the information inside. Here's a basic breakdown. Decentralization. Unlike traditional databases that are owned and controlled by a single entity, blockchain is decentralized. This means the information is stored on multiple computers, called nodes, spread across the world, making it more secure and resilient. Transparency. Every transaction or record added to the blockchain is visible to everyone in the network. This transparency ensures trust and accountability because anyone can verify the information. Security. Blockchain uses advanced cryptographic techniques to secure the data. Once a block is added to the chain, it's cryptographically linked to the previous block, forming an immutable chain. Changing the information in one block would require changing every subsequent block, which is extremely difficult and computationally expensive. Smart contracts. Blockchain can also execute self-executing contracts called smart contracts. These contracts automatically enforce the terms and conditions written into them, eliminating the need for intermediaries and reducing the risk of fraud. Overall, blockchain technology provides a way to store and transfer information securely, transparently, and without the need for intermediaries. It has applications in various industries, from finance and supply chain to healthcare and voting systems, revolutionizing how we manage data and conduct transactions. Let's imagine a library as an analogy for blockchain. Books as blocks. In a library, each book represents a block in the blockchain. Each book contains information, like transactions in a blockchain block, and is unique. Bookshelf as chain. The bookshelf where all the books are stored represents the blockchain. Each book is placed in sequence on the bookshelf, just like blocks are linked together in a chain in a blockchain. Librarian as miner. The librarian is like a miner in a blockchain network. Miners validate transactions and add new blocks to the blockchain, just like librarians organize and add new books to the library. Library card as transaction. Borrowing a book from the library is similar to making a transaction on the blockchain. When you borrow a book, your library card records the transaction, similar to how transactions are recorded on the blockchain. Library network as decentralization. Imagine a network of libraries where each library has its own copy of the books and library cards. This represents decentralization in a blockchain network, where multiple copies of the blockchain exist across different nodes or computers. Library rules as consensus mechanism. Just like libraries have rules for borrowing and returning books, blockchain networks have consensus mechanisms that ensure agreement on the validity of transactions and blocks. Overall, the library analogy helps understand how blockchain works by comparing it to a familiar system of storing and organizing information. The potential benefits of blockchain technology are numerous and include decentralization. Blockchain operates on a decentralized network of computers, eliminating the need for a central authority or intermediary. This decentralization increases transparency, reduces the risk of fraud, and enhances security. Transparency. All transactions recorded on the blockchain are visible to all participants in the network. This transparency ensures accountability and trust, as anyone can verify the information stored on the blockchain. Security. Blockchain uses advanced cryptographic techniques to secure data. Once recorded, data cannot be easily altered or deleted, making blockchain highly resistant to tampering and fraud. Immutability. Once a transaction is added to the blockchain, it becomes a permanent part of the ledger. This immutability ensures the integrity of the data and provides an audit trail for all transactions. Efficiency. Blockchain streamlines processes by removing the need for intermediaries and manual reconciliation. Smart contracts. Automated agreements executed on the blockchain further enhance efficiency by automatically enforcing predefined rules and conditions. Cost reduction. By eliminating intermediaries, reducing paperwork, and automating processes, blockchain can significantly reduce transaction costs for businesses and organizations. Increased trust. Blockchain fosters trust among participants in a network by providing a transparent and secure platform for conducting transactions. This increased trust can facilitate collaboration and partnerships among stakeholders. Global accessibility. Blockchain operates on a global network, allowing participants from anywhere in the world to access and transact on the platform. This global accessibility opens up new opportunities for trade, commerce, and financial inclusion. Overall, the potential benefits of blockchain technology span across various industries and use cases, offering innovative solutions to long-standing challenges in data management, security, and transaction processing. Certainly, blockchain technology can be applied across various industries and use cases. Here's a list of applications where blockchain can be used. Cryptocurrencies. The most well-known application of blockchain is cryptocurrencies like Bitcoin and Ethereum, which use blockchain to enable secure peer-to-peer transactions without the need for intermediaries. Supply chain management. Blockchain can be used to track the movement of goods across the supply chain, providing transparency, traceability, and authenticity verification. This is particularly useful in industries like food, pharmaceuticals, and luxury goods. Smart contracts. Smart contracts are self-executing contracts with the terms of the agreement directly written into code. Blockchain-based smart contracts automate and enforce the execution of contractual agreements, reducing the need for intermediaries and enhancing efficiency. Identity management. Blockchain can provide a secure and decentralized solution for identity management, allowing individuals to control and share their personal data securely without relying on centralized authorities. Digital voting. Blockchain-based voting systems can enhance the integrity and security of elections by ensuring transparency, immutability, and tamper resistance. This can help prevent election fraud and increase voter trust. Healthcare. Blockchain can be used to securely store and manage electronic health records, EHRs, facilitate interoperability between healthcare providers, and track the provenance of pharmaceuticals and medical devices. Financial services. Blockchain has numerous applications in the financial services industry, including cross-border payments, trade finance, remittances, and tokenization of assets such as real estate and securities. Intellectual property protection. Blockchain can be used to create immutable records of intellectual property rights, including patents, copyrights, and trademarks, helping to prevent piracy and unauthorized use. Digital identity. Blockchain-based digital identity solutions can provide individuals with secure and portable digital identities, enabling seamless authentication and access to services across different platforms and organizations. Real estate. Blockchain can streamline the process of buying, selling, and transferring real estate assets by providing transparent and immutable records of ownership, titles, and property history. Energy trading. Blockchain can facilitate peer-to-peer energy trading by enabling individuals and organizations to buy and sell excess energy generated from renewable sources directly to each other, without the need for traditional energy utilities. Supply chain finance. Blockchain-based supply chain finance solutions can provide secure and transparent financing options for suppliers based on the verifiable data stored on the blockchain. These are just a few examples of the many applications of blockchain technology. The versatility and potential of blockchain extend across various industries, offering innovative solutions to complex challenges. Let's consider a traditional supply chain management system as a series of handoffs between different parties involved in bringing a product from its raw materials stage to the hands of the end consumer. Now, imagine that each handoff involves passing a baton from one person to the next. Each person represents a different entity in the supply chain, such as suppliers, manufacturers, distributors, retailers, and consumers. The baton symbolizes important information about the product, such as its origin, quality, and ownership. In a traditional supply chain, there are several challenges with this process. Lack of transparency. As the baton passes through different hands, there is often a lack of transparency about where the product came from, how it was produced, and who has ownership at any given time. This can lead to issues such as counterfeit products, theft, and quality control problems. Data silos. Each participant in the supply chain may maintain their own records and databases, leading to data silos and inefficiencies. This makes it difficult to share information and collaborate effectively across the supply chain. Trust issues. Because there is no single source of truth, participants in the supply chain may not trust the information provided by others. This can lead to disputes, delays, and increased costs as parties seek to verify information independently. Now, let's introduce blockchain technology into this analogy. Imagine that instead of passing a physical baton, each handoff is recorded on a digital ledger that is shared among all participants in the supply chain. This digital ledger, or blockchain, contains a complete and immutable record of every transaction and handoff that has occurred. Here's how blockchain addresses the challenges of traditional supply chain management. Transparency. With blockchain, every participant in the supply chain has access to the same transparent and immutable record of transactions. This means that everyone can see where the product came from, how it was produced, and who has ownership at any given time. Data integrity. Because the blockchain is decentralized and distributed, there are no central points of failure or data silos. All participants have access to the same verified data, ensuring data integrity and reducing the risk of errors or fraud. Trust. Blockchain technology relies on consensus mechanisms and cryptographic techniques to ensure the integrity and security of the data recorded on the ledger. This creates a high level of trust among participants, as they can rely on the accuracy and immutability of the information stored on the blockchain. In essence, blockchain technology acts as a digital baton that streamlines and secures the flow of information and assets across the supply chain, resulting in greater transparency, efficiency, and trust among all parties involved.